Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Newton's method. We do a lot of things these days with our graphing calculators, but obviously they were not available many moons ago whenever the original mathematics and Greeks were working on things. So Newton's method, what's the point of it? Is to calculate a zero. Okay, and it's not going to be perfect, but it's going to be pretty accurate. So we're going to try this without a graphing calculator. So first of all, you have to have something that's smooth and continuous on an interval from A to B, okay? And either f of A needs to be greater than 0 and f of B needs to be less than 0, or vice versa, right? I don't care, as long as one's positive and one's negative. Then we know that we're going to have some C right here, okay? So let's think about this as far as like point slope form goes, right? We know that y minus y1 equals mx minus x1. All right, and I'm going to go ahead and C is the ordered pair 0, or x, 0. So 0 minus, I'm going to call it f of x sub 1 equals our slope, our C value, right? I'm going to call it x minus x sub 1. Okay, so let's solve for x. We'd have to divide by m first, right? And actually, let's go ahead and get away from m even. Isn't the slope of our tangent line the derivative at our x value? So negative f of x sub 1 divided by the derivative of x sub 1 is going to equal x minus x sub 1. So I'm going to add that x sub 1 over. And remember, this was my pink x. So x is going to equal x sub 1 minus f of x sub 1 divided by the derivative of x sub 1. And use iterations. So we developed that a little bit, so you can see that it's just the formula where I'm solving for this x variable, right? I'm just solving for the pink x. So I took my point slope form, I used function notation, and I solved for x. So Newton's method says that we can pick any old x sub 1 we want. So let's just go ahead and let's get an equation going here. F of x equals 2x to the third plus x squared minus x plus 1. Okay. And just to note, if we substitute 0, we get out 1. I'm not going to graph it yet because I don't want you guys looking at the graph online. I'm sure some of you have looked at home, but we are going to go to the table. What about negative 1? Okay, negative 2. negative 1 was 1, and negative 2 was negative 9. So we must have an intercept in between here, because that's greater than 0, that's less than 0. We've got to cross the x-axis somewhere between negative 1 and 2. So I'm going to call my x sub 1 negative 1. Newton says that to get x sub n plus 1, we do x sub n minus f of x sub n divided by the derivative of x sub n. And then we complete the process. So if x sub 1 is negative 1, then x sub 2 is going to equal x sub 1 minus f of x sub 1 over the derivative of x sub 1. Then x sub 3 would be x sub 2 minus over the derivative. See, this process is going to keep going. So we're just taking that last answer and putting it in. Okay, so before we go any further, our derivative, let's get that right quick. 6x squared plus 2x minus 1. Ooh, that went blurry. Give it a second. And I've highlighted all the variables. Check. Okay, so what I'm going to do here so I can save time is I'm going to type negative 1, enter, because that's my x sub 1. Then I'm going to take my x sub 1, which was my last answer. See how I use the key answer, minus, and I need to do f with my x sub n substituted in. So 2 answer to the third plus answer to the second minus answer plus 1. So it's going to substitute negative 1 everywhere it sees answer. 6, not negative, 6 answer squared plus 2 answer minus 1. Negative 4/3 is x sub 2. X sub 3, I just hit enter. X sub 4, x sub 5, whoa, those are almost 6. Okay, do you see how they're getting closer and closer and closer? We're accurate to 4 decimal places right now. We're seeing already that our x-intercept is approximately at negative 1.23375. I wrote that down. Okay, so now let's look at our graph. Ooh, I don't like that window. Okay, we can definitely see it crosses between negative 1 and 2. So if I calculate a 0, get to the left of it, get to the right of it, negative 1.23375. We just finally learned the formula that the calculator's been doing every time you've calculated a 0. So sometimes if it didn't come out to perfectly 0, that's because the calculator was running this iteration process, and it gets happy once it gets within so many decimals of the y being 0. And so occasionally you might have gotten y is like 0 times 10 to the negative 12th or something like that. Okay, so let's try another one. We're going to try the equation cosine of x plus sine of x plus 3x. Okay. So it looks like the first one's going to be somewhere close to 0. Okay, and to be exact, left, right, looks like it's approximately negative 0.24. Okay, so we have our answer from our calculator. Let's test this thing out. cosine of x plus sine of x plus 3x. We know it's crossing around 0, so my x of 1 I'm going to do is 0. You could do negative 1 as well. It doesn't really matter. Okay. Our derivative is negative sine of x plus cosine of x plus 3. So x can be approximated. So we have our derivative, and I put spaces everywhere where we're going to need to sub that x of 1 in, right? So I have 0 on my calculator. Then I'm going to hit enter. Negative 1/4, negative 0.24. That's already really close. X of 1, x of 2, x of 3. We're almost there. X of 4 changed a little bit, and now x of 5 is the exact same. So I would say we've hit this thing right on the marker, and if you remember from doing the graph, we definitely have the same exact value as we would have gotten graphically, except now we've done it with a basic calculator, and we could have done it without using the calculator if we'd wanted to do all the computations by hand, which, hey, they got to do back in the day, so thank goodness for your technology, right? Okay, so application. How might they ask you to do this? Find the point on the graph f of x equals x squared that is closest, oh, I can't spell today, to the point 4, negative 3. Okay, so what does this really mean? Well, we've got f of x here. And we've got a point 4, negative 3. And they want this distance to be minimized. Okay, so if they want the distance to be minimized, we need to set the derivative of distance equal to 0. Okay, so we're going to use the ordered pair x comma x squared because that's what that would be, because it's x comma y, right? We don't want multiple variables. We want to keep everything pretty the same. So distance is going to equal x minus x squared plus y minus y squared. Okay. So distance squared equals 16 minus 8x plus x squared plus 9 plus 6x squared plus x to the 4th. I was thinking about squaring both sides, and then I remembered, nah, I don't want to do that. Okay, so like terms, actually I could square both sides. And I'll keep it though, x to the 4th plus 7x squared minus 8x plus 25. So this is not what we're setting equal to 0 though. So we can't do Newton's method to this. Newton's method is just to find a 0. Okay, so now I need to derive that. 1/2 all of this the negative 1/2 multiplied by 4x cubed plus 14x minus 8. This is what we're setting equal to 0. Okay, I can multiply this over. Okay, so I'm wanting to find this 0, because finding this 0 will have our distance minimized. So remember, x sub n plus 1 will equal x sub n minus f of x sub n over the derivative. That would be 12x squared plus 14. So there we go. Okay. So we know we don't want to get too far from 4. I don't care what our start number is. Do you want to go 2? There we go. It looks like we're pretty consistent here. 0.529106. So that's going to be our x value. So our ordered pair is going to be basically 0.529. And our y value is going to be that squared. So if we just square it, 0.277 or 0.2799. Now we have the point that's going to minimize the distance. Okay, so please keep that in mind, that it's what you're trying to find is a 0, okay, that you do Newton's method with. It's after you set it equal to 0 that you can apply Newton's method, not before. So we didn't do it to the distance formula, we did it down here. Once this was nice and something, we did Newton's method. And again, the whole reason behind it is so that we can calculate without the calculator. If you wanted to check though, take a look at that graph. Okay, we can see it coming in. I'm to the left of it. Remember we said 0.529. And there it is. So definitely are able to do it without the graphing part, just by applying Newton's method. We could technically do it with a basic scientific calculator now. We would not need the graphing calculator to get to our needed values.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.